Hey everyone, just to let me know, am I audible? Right now I'm not visible, but can you hear me, my dear friends? Is your Baba HSP audible to you? क्या आप मुझे देख पा रहे हैं? I want to know this thing. If yes, show me green hearts. अगर आप सभी को मैं दिखाई पड़ रहा हूँ, I want to see green hearts. Jyoti Jain, little Arjun Prakash, yeah, little Cupid, everyone. Wow. That means your Baba is audible to all of you. Namaskaram. Welcome to each and everyone. And I would like to say welcome to Hydrocarbon and Alkane. This is the most important topic, kids. But Baba want to see all the green hearts and fire symbol in the chat section. If you can hear me, can see me. If your Baba is completely audible and visible, perfectly audible and visible, I want to see green hearts. And how is the Josh, my dear friends? In hydrocarbon, I will take 3 sessions. One for alkane, another one for alkene, and the third one for alkyne. So kids, most of the people, they find this chapter really very difficult, but I would like to say this is very easy. In Tamil, if I say that this hydrocarbon alkane looks idiappa murku, means tough, puzzled, but I would like to say I will make it nalla eriku, romba sulubham. Just like organic chemistry padikkaradu kastama, but I would like to say let's romba sulubham means what I said in Tamil, that is, it looks like tough to understand organic chemistry, alkanes, hydrocarbons, but once you are able to understand, it becomes so simple, so easy, so that each and every reaction you can solve, my dear friends. So we have to make it easy peasy lemon squeezy. Is everyone ready? I want your promise, kids. Say that yes, we are ready. Then Baba will start. Yes, kids. Along with the Champa story, Pandu story, number of stories, along with full entertainment, along with in-depth knowledge and the questions, I will start this chemistry with each and everything. But before that, let me show you something, my dear friends. Hey, Sim, come on. Where are you? Hey. Your favorite star faculties, the most intelligent bio queen, your Ambika ma'am. You know very well your Ambika ma'am, kids. Say hi, ma'am. How are you? The most talented teacher of bio, kids. Now the Wasim the Great, our hero, Thalaiba, Wasim sir. Now Yawar sir, we cannot forget about physics faculty, Yawar sir, the best physics faculty who is going to change the NEET game, my dear friends. He is very awesome teacher of physics. And myself, your Baba HSP, simple but simply super. Oh, my dear friends, now, what is here? NEET 2026 batch by Team Avengers. You can see the Avengers team. We are Avengers. Full on Josh. NEET 2026 batch for Nimbus. That means a nurture batch, class 11th batch. You can get enrolled over here in live now, enroll now, and terms and conditions. This is just for rupees 5,999. Let me close the door, kids, so that no extra noise should come. Now it's closed. Now see, my dear friends, what's next? Phoenix Pro batch. Everyone knows this. Once again, by Team Avengers, last fully live batch, now at just rupees 5,999. Very less price. Live now, enroll now, terms and conditions, and number of lectures 600 plus number of test kits. Now these are our centers with India's best faculty for Plus, Iconic and Pro batches. Now my dear students, NEET UG flashcards, you can see whatever is written over here directly. Now I would like to focus on the team, the best team, India's best team to teach in English. Say kids, am I right or wrong? If Baba is right, everyone, you are getting this team just for rupees 5,999, my dear students. Nowhere you will get these fantastic teachers, whether we teach on YouTube, in the batch, or super live classes, free classes, everywhere kids, you are getting the quality content. If I'm right, if your Baba is 100% is correct, then just to let me know in the comment section that, sir, whatever you are saying, you are 100% true. You are not lying. You are just telling us the truth. Nowhere we are getting this type of quality content. Show me green hearts. If whatever I'm telling you, I'm 100% correct. Now kids, with all these things, this is offline centers. You know, right now, I'm taking this class from the offline Jaipur center. I teach here for IIT JEE advanced batches. I'm taking over here, my dear students, and that is at Jaipur center, offline center. So see, the greatness of offline center across India, everywhere in the India, that our Unacademy centers are present. And right now, Baba is present at Jaipur. Jaipur, the best rank producing place, the pink city. And now I'm teaching you online at this platform, yours Unacademy NEET English channel in English kids. So everywhere Baba is present. Now kids, let's start with our hero hydrocarbon. Everyone ready? I want to see some fire in the chat section. If everyone is ready, kids, show me some fire in the chat section. So we are going to start with alkane hydrocarbon. Hey alkane, where are you? We are waiting for you. Alkane, our hero alkane. The molecular formula CnH2n plus 2. Now my dear students, just to let me know one thing in the chat section. You want to study alkane like as usual you were studying, or you want to get something best from the alkane in new style? You want to study in new style? Just to let me know in the chat section. Let me just read out the chat. What my kids wants. What my kids wants. Hey, hey, hey. Everyone hit the like button. Your Baba HSP is asking to you why the likes are less. Kids are, number of kids are there, my dear students. Why likes are so less? Everyone smash the like button, kids. Everyone hit the like button. New style. Jyoti Jain is saying new style. Very good. Any Telugu people? Surya. Now Sahana, thank you. New style. Sahana, Hanumek Nayak, Hanumesh, Surya, Rani, Ratan Sethi. Hey, welcome Ratan Sethi. Now, my dear students, everyone smash the like button. Baba want to see more and more likes. Kids, your likes are very less. Everyone, kids, everyone, mark your attendance. Rishmita Mahabharat, new style, sir. Okay. But first of all, I will start only when you are going to hit the like button, kids. Everyone, I want to see at least whatever the number of people are there, that those many likes should be there, kids. Now, see, this CnH2n plus 2 is saying I'm saturated. I'm saturated. Now, my dear friends, you know one thing very clear. Very clearly, you know one thing. If you have already full on stomach, you have eaten too much, will you be ready to eat? No, sir. When we are hungry, then only we are going to eat. So they are saying we are saturated, like CH4, full on hydrogen, C2H6, full on hydrogen C3H8, full on hydrogen C4H10. They are not having any deficiency. They are full on of hydrogens. They are saturated. They are not having pi bond. When they are not having pi bond, they are not having alkyl halide. Just see, let me tell you kids. Let me tell you one thing, just see to it. If I say that if there is alkene, if I consider alkene, this is highly reactive because of pi bond. If I consider alkyne, it is highly reactive because of 2 pi bonds. If I consider Rx, it is highly reactive because of polarity. If I consider aldehyde ketones, they are highly reactive because of polarity. If I consider any group, they are highly reactive. Agreed? If yes, don't forget to write down there that yes, you are agreed. You can show thumbs up or green hearts if you are agreed. Remember that you have to show green hearts if you are agreed. Kids, I want to see green hearts if you are agreed. Now, they are highly reactive, and once the compound is being highly reactive, then the chapter will be very big. Why the chapter will be very big? Once anything is highly reactive, that will show many reactions. These will show many reactions. Will show many reactions. Will show many reactions. And many reactions means chapter will be lengthy. Chapter will be lengthy in this case. Sir, what are you doing? You were about to start hydrocarbon and you have written alkene, alkyne, alkyl halide. Are you not going to teach hydrocarbon alkane? Kids, just wait. What I'm saying, I'm comparing this with alkane. Our alkane, they are fully saturated. They are neither having any pi bond. They are not having any polarity. No polarity. No pi bond. What do you think? Our hydrocarbon is highly reactive or least reactive? Write down in the chat section. Don't be so lazy. Always keep on writing on the chat section that it is highly reactive or least reactive. It is going to be least reactive. It will be least reactive. Now, that means hydrocarbons' chemical properties will be very, very less. So we will not be having many chemical properties, but whatever the chemical properties are there, they will be free radical substitution reaction and they will require high temperature. But before that, we will focus on preparation, physical properties, and then chemical properties. Our motive will be on 3 things. What are these 3 things we are going to study today, kids? One thing is, we will focus in preparation of hydrocarbon, then chemical properties of hydrocarbons, chemical properties, and then we will see all the physical properties, these 3 things. Now, which thing is going to take maximum time? Out of these 3, this is going to take maximum time. Why? Because number of chemicals will be used for its preparation. Are you ready? Is everyone ready, kids? So let's see. Let's start with the preparation. Preparation of hydrocarbon. Preparation number 1 starts with the most important reaction that is known as soda lime reaction. Soda lime reaction, also known as decarboxylation. What? Decarboxylation. Its another name is what? Decarboxylation. These 2 names are there. There is one more name for this. that is lab method preparation. Lab method preparation. Now let's see, this reaction looks very simple. That Rexona, do you remember? RCOONA, Rexona. Everyone say Rexona. Sodium carboxylate plus NaOH in presence of quicklime, that is calcium oxide, and you will get, what you will get, kids? RH plus Na2CO3. Now my dear students, see, this is the catalyst. I would like to say COO is used as catalyst. It is what type of nature? You know that our NaOH is deliquescent in nature. Deliquescent in nature. So this is hygroscopic in nature. What is the difference between hygroscopic and deliquescent? Anyone? Difference between deliquescent and hygroscopic? Can you tell me in the chat section? Kids, keep on showing the sign, otherwise Baba will say, hey kids, Kiran Pathak, Ratan Sethi, very good. Now I want to see everyone's response in the chat section. Kids, if you are giving response, then only you are going to get benefited. Now see, deliquescent means which absorbs moisture from the atmosphere and themselves gets wet. जो पानी absorb करे और खुद गीला हो जाए. But hygroscopic is going to absorb moisture from the atmosphere, but itself it is not going to become wet. Moisture दोनों ही absorb करते हैं. Both of them, they are going to absorb moisture, but one is becoming wet, another one is not becoming wet. So this is not becoming wet. Now kids, you see COO, this hydrocarbon is having one carbon less. One carbon less. Now my dear students, this one carbon less is indicating that there is shortening of the chain. What kids? What is there? There is what? There is shortening of the chain. Remember that whenever you are required to do shortening of chain, then you need the soda lime reaction. The parent hydrocarbon will be one carbon less than the parent acid. Getting my point? One carbon will be less. Now let's see the examples. Are you ready, kids? I want to see some green hearts, some thumbs up, some fire in the chat section all the time. If you are able to understand, one page is completed, one page you are able to understand, then show me some green signal. If any doubt is there, then I want to see fire in the chat section, because from this much distance of that laptop is there, and this distance, it is too much. I cannot see whatever you are writing in the chat, but I can see they are green. They are fire. If you are not able to understand, any doubt, fire symbol. If everything is green means to go ahead. Got it? Wow. Yeah. Now see, kids. Example number 1, the simplest example. Just see simple most example. If I take CH3, COONA. Now my dear students, remember what is the name? Name is sodium acetate. This is the journal name. What should be the IUPAC name? Sodium athenoate. Remember that athenoate, 2 carbons are there. Now if you add zapak, NaOH calcium oxide. Now see, this is methyl. You will get 1 carbon less. CH4 plus Na2CO3. Now, in your mind, one thing must be coming, kids. It's almost... Now, kids, you must be thinking one point, sir. By chance, if examiner is giving acid, then what will happen? Because, sir, this is base and this is sodium salt of acid. Now, by chance, if examiner is giving this question like this, CH3 COOH plus NaOH excess. Now, my dear friends, whether excess is written or excess is not written doesn't matter. Always it is the demand of that chemical reactant. It will use whatever the amount it is going to use. So this is an acid. This is a base. So acid-base neutralization will take place very fast. Acid-base neutralization will take place very fast. CH3COONA. Now we got CH3CONA. And now once again NaOH will come. NaOH along with calcium oxide. Now you will get CH4 plus Na2CO3. Now kids, this is the simple question. Now by chance the question is tough. Now how will you do it? How will you do it? Let me tell you, my dear students. Suppose if anyone is going to give you compound like this, R, C double bond OOH. Now what is the mechanism? Because tough question can be asked on the basis of their reactivity, rate of reaction, increasing order, decreasing order, any type of question they can ask. Now see kids, just see to it. I'm saying that if you are going to heat it, just see what is going to happen. If you supply heat, just see this compound. This is having delta negative and this is having delta positive. So let's leave this charge, apply heat sign. This is H delta positive, and from where this bond is going to break? It will break from here. That means this R will take its electron as well as the electron of carbon. So it is gaining electron, gaining electron, gaining electron. This part is gaining electron, my dear students. So it will develop with charge. Kids, you have to think like you're sitting in front of me. Just I'm teaching like one-to-one. I'm taking one-to-one class. Whenever I'm asking something, everyone have to respond. Kids, in this way, you are not going to get the rank. You have to respond. Write down who is going to get negative charge. I want to see this carbon will, this R will develop negative charge. Now see what is going to happen. Everyone just see what is going to happen, kids. This H plus and this R negative will combine together, Now what will get released? This CO2 will get released. Zoom. This will go away. Hey, I'm to leaving. So it will get away as like this. CO2 will get released. Now R got H. So R is saying, hey, I'm yours. So my dear students, carbon dioxide has been released. That's why it is known as decarboxylation. That's why it is known as what? Decarboxylation. Everyone is able to understand why it is known as decarboxylation reaction, kids. Kids, do let me know, everyone. Everyone do let me know. Everyone do let me know that why it is known as decarboxylation reaction. Kids, you got it or not? Just to let me know. Everyone just to let me know. I want to see everyone is able to understand or not, kids. Carbon is releasing. That's why it is known as decarboxylation reaction. Decarboxylation. That's why it is known as decarboxylation. Now, my dear students, I would like to tell you, during this reaction, R got negative charge. So who is the intermediate during this reaction? Remember that R negative is the intermediate, and I will say R negative is what? Carbanion. Carbanion is the intermediate. Now, my dear students, if they are going to ask tough question, what you will say? Rate of reaction is directly proportional to. Rate of reaction is directly proportional to what? Stability of carbanion. Rate of decarboxylation reaction, if anyone is going to ask, rate of decarboxylation is directly proportional to what? Rate of decarboxylation is directly proportional to stability of carbanion. Kids, don't forget stability of carbanion. Stability of carbanion. Now, in GOC, I taught you what? When I was teaching you GOC, what I have told you, kids? Do let me know. That carbanion stability depends on AR, BBSI. The resonance stabilized carbanion is going to be the most stable. If you remember this point, kids, you can do anything. That SBR, stabilized by resonance carbanion, is most stable, and after that 1 degree carbanion, then 2 degree carbanion, then 3 degree carbanion. This is the stability order. Now, after telling you this much, Baba is going to ask one question. I want to see answer in the chat section. Everyone, just answer it, okay? So question is arrange the following in decreasing order of decarboxylation rate. Decarboxylation rate. Now, what are the options? Just see. Options are: A is CH3 COONA, B is CH3 C double bond O CH2 COONA, C is CH3 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 COONA, and D is CH triple bond C COONA. Now let's see who is going to give the correct answer. Baba is going to wait. Baba is waiting in the chat section. Let's see who is going to give the correct answer, my dear students. Everyone. Stability of carbanion. Yes, that was the stability of carbanion, my dear students. Now let's see who is going to give the correct answer. Baba is waiting for your answer, my dear students. No. Give me the order. NEET warrior. Order. You have to write down the order for reactivity. I want to see who is going to win this race. Who is going to give the correct answer for this question, my dear students. Baba is just waiting for answer. Wasim Akram. Wow. DCBA. Wasim, your answer is wrong. Sorry. Now let's see who is the next candidate to give. CBDA. Jyoti Jain Kushiga, your answer is wrong. Your answer is also wrong. Now let me see. Sahana, your answer is also wrong. Now kids, most of the students or all the students, they have given wrong answer. Now let me explain why. Just see to it. Everyone, just see to it. Why I'm saying that your answer is wrong. Just see. Kids, if this is taking electron, this will become carbanion 1 degree. 1 degree. And this is sp3 hybridized. So whenever the carbon is sp3 hybridized, its electronegativity is 2.5. Now see, if this is going to become carbanion, now see, its charge will do resonance. Can you see, kids? its charge will do resonance with this oxygen. Can you see kids? Its charge will do resonance, stabilized by resonance. So this is going to be the most stable carbanion. Am I right or wrong? Most stable carbanion, most stable carbanion, kids. Are you getting my point? Now this carbon is more electronegative, so on the second number this will be, because it is triple bonded sp hybridized, and this is 3 degrees, so this will be at the last. So your answer will be definitely B, after B D, after D A, then C. Agreed or not? Are you agreed? If agreed, show me the green hearts, green leaves, whatever green, anything green you can show. If you are agreed, kids, I want to see that my students, lovely students, they are able to understand or not. Kids, very slow answer. Your answer is not coming fast, kids. What's that? I want to see answer, fast answer, kids. Everyone. BDAC. Agreed, everyone. Jeevan, Shaktivel, Sausi, welcome Sausi, Jyoti. Kids, everyone, call all your friends. Baba is teaching. If Baba is really giving the best content, then you have to call each and every friend. Kids, Kailash, Raja, everyone, call your friends if Baba is really giving the best content. Now, question number 2. Just see question number 2, everyone. Question number 2. Give marks to yourself. Decreasing order of decarboxylation rate. Decarboxylation rate. Now see, everyone, just see to it. A. C double bond O, COOH. B. CH triple bond C, CH2, COOH. C. CH3, CH3, COOH. D. CH3, COOH. This time I want clear-cut answer, then I will tell you one greatest thing, kids. I want to get clear answer. Everyone. Everyone, fast. Yes, let me check it out. Who is going to give the best answer? Means the correct answer. Everyone, fast. I want to see everyone's answer. Please get fast. Everyone, quick. Then if you are going to give the correct answer, Baba will give you one memory chart after telling you all the preparations. Surya Hero, Sahana. So let's see who is going to give the correct answer. My dear students, A, B, C, D. This Kailash Raja and Sahana and Hariharan, your answers, Amanja, you people's answers are correct. Now see, just see to it. Once again, if you focus over here, this will get negative charge, and negative charge will do resonance. It will do resonance with this oxygen. It will come over here, it will do resonance. So it is being stabilized by resonance, more stable. and this carbon is sp hybridized, so it will withdraw electron from here. This will get negative charge, so it is having minus I order, and now it is 2 degree carbonyl, 2 degree carbonyl, and this is being 3 degree carbonyl, my dear students. 1 degree carbonyl, then 2 degree carbonyl, then 3 degree carbonyl, and maximum stable is stabilized by resonance. So this is the stability of carbonyl, and once the stability of carbonyl we have seen, kids, stability of carbonyl we have seen, we can say the order will be definitely very clear cut order. So this is A, after A, B, then C, then D. This is going to be the correct answer. Now, in two compounds, you have seen one thing is being common. Now, Pava is going to give you the best thing. Just see that any compound like this, RC double bond O, CH2, COOH, whenever you see this type of thing, what is this? With respect to this functional group, this is being functional group, this is alpha carbon, this is beta carbon, and beta keto acid. Whenever you see beta keto acid, then remember that the carbon ion is going to be stabilized by resonance. Whenever you see beta keto acid, always remember that one thing, that carbon ion will get resonance stabilized. So no need to do soda lime reaction. Simply on heating, that carbon dioxide will get released. This carbon dioxide will get released, and you will get compound. You will get compound like RCO, CH2H. Not to do any soda lime reaction. Carbon dioxide will get eliminated out automatically, my dear students. There's no need of doing soda lime reaction. Now, my dear students, this much is clear. If yes, show me green signal, and then let me move towards another reaction. Now the second type of preparation is that you are having any carbonyl compound like this. This can be aldehyde because R can be hydrogen, R can be alkyl, R can be aryl. So this compound can be what? This compound, aryl means aromatic. This compound can be aldehyde, I would like to say. It can be aldehyde or it can be ketone. Now, our focus is to remove this oxygen and to place what? Just to place hydrogen on that carbon. We want to remove that hydrogen and we want to place two hydrogens. Then it will get converted into hydrocarbon. Now, how can we do that? How to do this thing? There are three types of methods. Method number one, my dear friends, this is known as wolf. Hey, everyone say wolf. Wolf, sir. Wolf is animal. No. Wolff-Kishner reduction. Wolff-Kishner reduction. What you will do in this Wolff-Kishner reduction, kids? In this Wolff-Kishner reduction, we have to take Nehatu. What is Nehatu? Nehatu. 2 times Nehatu, kuhu, and ethylene glycol. So this reaction's name is Wolff-Kishner reduction, and this is carried out in basic medium. This is carried out in which medium? The basic, because this is basic medium. So this is basic medium. This will convert hydrocarbon into aldehyde ketones to hydrocarbon. Now, second type of reaction you can use, its name is, yes kids, if you remember, if anyone remember, just do let me know in the chat section. What's the name? I want to see in the chat section if anyone remembers. So its name is Claymanson's reduction, Clemenson's reduction. You can do this conversion by this also, either with this method or you can carry out Clemenson's reduction. Now, which chemical you have to use? Hey everyone, if anyone remembers, do let me know which chemical you have to use. Sir, I know. Yes, then tell me. Zinc amalgam, and HCl. This is used in this reaction. Now, there is one more, but remember that this is in being acidic medium. This reaction is carried out in acidic medium. Now, the third method, if you want to opt, this is the third method, you can go with what? HI red phosphorus. HI red phosphorus. Now, there is no name, no scientist name. These are the three methods by which you can convert aldehyde or ketone into hydrocarbon. If this is clear, show me the green symbol. Green symbol gets you are very, very lazy kids. If you are getting it, just do let me know. I want to see, yeah, that NH2 is hydrogen. Very good. Yeah. You got it. Hydrogen. Kids, you have become lazy. I don't want to see that. Kids, comment or give green hearts if this is clear. I want to see your symbols, but it is becoming very dry, kids. Baba is helping you so much. Hard efforts Baba is putting, kids. I will start crying. This is hydrogen. Baba will start crying. The man, the teacher who is responsible for producing so many ranks year on year, first rank, second rank, third rank, both in IIT, JEE and NEET. This lecture is important for everyone, kids. You are preparing for JEE Advanced, JEE or NEET. You will get best rank. Then you are so, yeah, now I got it. Thank you. Dhanyavadam. Now see the third, how we can prepare. Just see the third preparation. Its name is very well-known reaction, Wurtz. It's not Wurtz Khalifa. Remember that. People will say Wurtz Khalifa. No. Wurtz reaction, just Wurtz reaction. Do you know what is Wurtz reaction? Wurtz reaction. It's not Wurtz Khalifa. It's simply Wurtz reaction. What is there? Just see to it. RX, 2RX, and in the middle there is twice of Na. Just see what is going to happen, kids. RX, racks, rocking racks. But it should be either 1 degree or 2 degree. Should not be 3 degree. Never ever be 3 degree. Never take 3 degree. Otherwise, this reaction is not possible. 1 degree or 2 degree? 1 degree or 2 degree. They are same. Now what is going to happen, everyone? Just see to it. NaX will eliminate out. Can you see this movie? NaX, NAX will eliminate out. This NAX will eliminate out. And what you will get, kids? The product will be RR. Twice of NaX. Now see. Symmetry is there. Can you see the symmetry? This alkane is being symmetrical. Can you see the symmetry is there? Whatever is on right hand side, the same thing is on the left hand side. Right hand side, left hand side. Both are same. What is on the right hand side, that is on the left hand side. Right hand side, left hand side. Both are the symmetrical alkane. You will get symmetrical alkane. La. I have got symmetrical alkane. Symmetrical alkane I have got. Now if anyone is saying, Champa, what are you saying? Champa is saying, I want to make unsymmetrical alkane. Sir, first give me example of this, then make unsymmetrical. Okay, Champa, just wait for seconds. Let's deal with some examples. Okay, so methyl chloride is reacting with methyl chloride, twice of Na, what will happen, kids? This will eliminate out this, you will get ethane. This is the simplest alkane which you can prepare. Methane can't be prepared from this method. Twice of NaCl. This is the smallest alkane you can prepare. Now, my dear students, now if I write down one reaction, then you will say, sir, what is that? It's not that easy, kids. Number of problems are there. Now, if somebody has taken methyl chloride plus ethyl chloride, then what do you think? Is there any problem? What you will get as the product? Na dry ether. Do you think any problem will be there? Sir, it's so simple. Hey, Champa, just please. Champa is my assistant. Always she is interfering. Let the students give the answer. Is there going to be any problem? Yes, sir. There will be problem. Arey, what problem? Sir, you know, when you carry out any reaction, there are a number of molecules. Yes, I know, Champa, I know. Now, this will say, I will do this reaction, and when this is going to react, it will form CH3, ethane. Sir, it is a gas. Yeah, I know it is gas. Now, sir, when it's going to combine with itself, it will produce C4H10, and this is also gas. Butane gas. Yeah, I know, Champa. Why are you talking like this? Now, sir, both will combine together. Oh, Champa, what do you want to say? Sir, one from this and one from this. So, you will get CH3 and CH2, CH3. Oh, Champa, thank you. This was not coming to my mind. Champa, thank you. Really thanks. A lot of thanks to you. You made my day. Why, sir? Why? Oh, this is also gas. Oh, Champa, this too I know very well. This is also gas. Now, what's the problem, kids? They all are being gases. We have got mixture of 3 types of gases, and once 3 gases are mixed, it's not easy to separate them. It will take too much labor cost. You know that the COVID time, there was scarcity of cylinders, oxygen cylinders, but you see in the atmosphere, nitrogen and oxygen is there, but you cannot separate them easily. So, separating this mixture of gases is a very tough job, and that's why what I want to say, mixture of gases will take too much time and money for separation, and that's why it's not economical. Now, the ultimately result is preparation of alkane with odd number carbon, or we can say unsymmetrical carbon, unsymmetrical alkane is not economical, Why, kids? Because somebody has used this mixture of alkyl halide, this and this. His aim was to prepare propane. He has prepared propane, but you can't separate it. If you want to prepare ethane, you would have taken methyl chloride. If you want to prepare butane, you would have taken ethyl halide. But if you want to prepare propane, you have to take mixture. Otherwise, you can't prepare this type of alkane. But it's not easy to separate out, and that's why alkane with even number of carbon atoms are prepared by this method, and odd number of carbon atoms are not prepared by this method. Is this clear to each and everyone? I want to see green symbol if it is clear. Now, my dear students, the scientists, they have seen when they were provided with this compound, C2H5 Cl, and they have reacted with sodium and dry ether, kids. Sodium and dry ether. What they found? They got butane, okay, no problem. But along with butane, they have got one compound which is used for ripening of fruits, ethylene also. Now they got shocked how this is prepared. So ethane gas formation made scientists to create some possibilities of some mechanism, some other route. Now my dear students, let's see. Now kids, I think you got tired. What happened to rest of our students? Where they have gone, kids? Now kids, just see what Baba is going to tell you. Now the mechanism of this reaction follows two types of mechanism, ionic mechanism as well as free radical mechanism. This reaction follows ionic mechanism as well as free radical mechanism. And the answer of this question can be given by free radical mechanism. Now let's see what is that free radical mechanism, kids. So CH3, CH2Cl will eliminate out by free radical mechanism. Fish arrow, one electron will be taken by chloride, one electron will be taken by this compound. Now it will form CH3, CH2 free radical. Right, kids? Now once this is formed, now the possibility of combination, there are two types of possibilities. Just focus on the possibility. One combination is in major amount that ethyl can combine with ethyl free radical. Ethyl and ethyl, they can combine to form butane, CH3, CH2, CH2, CH3. The second possibility is that they can do reaction like this, CH3, CH2, CH2, CH3, and that reaction is known as disproportionation reaction. Kids, which reaction? Disproportionation reaction, my dear student. Disproportionation. Now what is going to happen in this disproportionation reaction? This molecule will lose electron, or you can say this will lose hydrogen. How it is going to lose electron? Just see. If I tell you CH2H, CH2 like this, and this will break the bond from here, this will break the bond from here, and this hydrogen will go to that. Now see, this compound will become like this, CH2 free radical, CH2 free radical, just see, and this hydrogen will go to that compound. It will gain that hydrogen, and this will become CH3 ethane, but this will form bond, free radical. Right now 7 electron and 7 electron, both carbons are having 7 electron, and they will form ethylene gas. I hope this point is clear. This will be formed in traces, means very less amount. It will get formed in less amount. If this is clear, I want to see green symbol, kids. Just to let me know, is it clear to all of you or not? Good evening, Epic. Now kids, Baba is going to give you memory map. Should I give you memory map? Everyone, just to let me know, should I give you memory map? Write down. Should I give you memory chart for hydrocarbons? Okay, let me give you one memory chart and then I will tell you preparation. Okay, let me give you. Thank you, Sahana. Thank you, little Everyone just see, Baba is going to give you one memory map. Memory chart or mind map. We can say mind map. Mind map. Let me start this mind map from methane. Just see, I am going to start with methane. Everyone, you have to help me. I want your help. Methane, also known as marsh gas, methane. Now just see, if I react methane with Cl2H nu, I will teach you this is free radical substitution reaction. You will get methyl chloride, my dear students. Everyone, methyl chloride. Now this name is methyl chloride. Methyl chloride. Now my dear students, if I react it with twice of Na dry ether, what I will get? Twice of Na dry ether. What is the name of reaction, kids? The name of reaction will be Wurtz reaction. Which reaction? Wurtz reaction. Wurtz reaction. Wurtz reaction. What I will get? Double of that. Double of that I will get ethane. CH3. CH3. Till now it is clear? Till now is it clear, kids? Just to let me know, till now it is clear. I want to see kids, till now it is clear or not? Everyone, you have to help me. Ethane. We will get ethane. Ethane I have got. Now, if the same reaction, if I carry out with Cl2H nu, what I will get, kids? Cl2H nu. Once again, it is free radical substitution reaction. I will get CH3, CH2 and Cl, ethyl chloride. Now from here, two paths will be there. Two paths. What are these two paths? See, one is being, if I reacted with KOH alcoholic, alcoholic KOH and heat. Now elimination will take place and I will get CH2 double bond CH2 ethane. Now another path is gets, if I react this with KOH aqueous will do the substitution, nucleophilic substitution reaction, and definitely I will get C2H5OH, ethyl alcohol. Now from this ethyl alcohol, two paths are there. What are these two paths, sir? Now one path is saying that if you react this with concentrated H2SO4, at 443 Kelvin, you will get this, and the name of this reaction is dehydration, known as acidic dehydration, kids. And once again, if you add water to this in presence of dilute H2SO4, this is a reversible reaction, and this is known as acidic hydration. Is it visible, kids? I hope this is visible to each and everyone, but let me complete that round circle. Now the round circle Baba is going to complete, and if I reacted with bromine water, what is the color of bromine water, kids? Bromine water is reddish brown. Bromine water, Br2, is reddish brown. Now my dear friend, this reddish brown bromine water will lose its color. The color will get decolorized. Why? Because bromine and bromine will get separated out and you will get CH2Br and CH2Br. What should be the name of this compound? Ethylene bromide. Name is ethylene bromide, but there is not ene. Remember that. Ethylene bromide. It's ethylene bromide. Now, if I react it with KOH alcoholic, now my dear students, just remember KOH alcoholic and heat will do the elimination. Now see what is going to happen. One Br will go from here, Br negative, so this carbon will develop positive charge, and one proton will go from here negative, so HBr will eliminate out. One bromine from here, one hydrogen from there, bromine from here, hydrogen from there. Now you will get compound like this, vinyl bromide. Now my dear students, in this vinyl bromide, the bromine's lone pair is doing resonance with this, so it's vinylic bromide. It's very tough to remove this bromine. Now alcoholic KOH will not work. You need some stronger base. Now stronger base is NaNH2, and that's why in NCERT it is written soda amide plus heat. Why this is stronger base? Because this has formed from ammonia. Ammonia is weak acid. Weak acid's conjugate base is going to be strong base. Now you will get acetylene. What you will get? Gets acetylene. Now if you add water to acetylene, now how will you add? Because this is very less reactive. 1% HgSO4, that is the catalyst you have to use. 1% HgSO4 and H plus. Now this will form CHOH double bond CH2, and it will tautomerize. It will tautomerize, kids. Tautomerize to give CH3 CHO. Now my dear student, this CH3 CHO use SOA. SOA is strong oxidizing agent like KMNO4, acidic medium. Now it will get converted to CH3 COOH. Now do the soda lime reaction, that is NaOH, calcium oxide. Now you will get methane. The whole chart got completed. Now directly if you want to convert this ethyl alcohol into acetaldehyde, then you can use mild oxidizing agent, and the name is PCC, pyridinium chlorochromate. And if you want to convert this back to ethyl alcohol, you can use LiAlH4 and ether. Kids, this is the best memory chart, the basic memory chart. If you're liking it, just to let me know. I will give you number of memory charts so that your organic chemistry is going to become simply awesome. Kids, do let me know. You're liking it. Sahana to written, yes sir, very good. You can use NaBH4 also. NaBH4, number of reagents you can use, but kids, do let me know you're liking it or not. Jyoti Jain, yes. Mind map number 1. Danish. Kids, everyone do let me know that are you liking it, loving it. At least show me your gratitude, kids. You are loving it, liking it, then only Baba will give you more charts like that. Otherwise, why I should give you more charts, kids? Everyone, very good, kids, very good. Love from Kashmir. Danish, thank you, Danish. Now, first of all, do let me know the writing is clear. Is it clearly visible? Because number of things. Jeevan, kids, these mind maps will increase your marks, will give you 100% accuracy. Jyoti Jain is saying this chart is in my room. Very good. Now everyone do let me know. Ananya Rajkumar, writing is visible. Is it whatever I have written, it is clearly visible? Each and everything, can you see, kids? Just do let me know. Everyone do let me know. Is it clearly visible? Very good. Wow, that's really awesome. It's a battery. Everyone, that's really fantastic. Now, let me tell you something more, some more preparations, some type of more preparations. Let me tell you, kids, okay? Now, see, kids, more preparations, then I will tell you chemical properties, right? First of all, more preparations of our hydrocarbon, some more preparations. Just see, can we prepare it from alkyne and alkene? Yes, the answer is yes. Preparation from fourth preparation from alkyne and alkenes. How will you prepare, kids? Just see, if I am provided with alkene, that is ethene, or I am provided with acetylene, any alkyne or any alkene, they are having less of hydrogen. So if I add hydrogen, one molecule of hydrogen in presence of any catalyst, nickel, palladium or platinum, 2 moles of hydrogen in presence of any catalyst, nickel, hydrogen or palladium. So I will get ethane. This point is very much clear to each and everyone, kids. Is this clear to each and everyone? This is the 4th preparation and its name is hydrogenation, and this I have told you during hyperconjugation heat of hydrogenation. So this is known as hydrogenation reaction, right? Now my dear students, after this let me tell you the 5th preparation. What is that? From benzene diazonium halide. Do you know what is benzene diazonium halide, kids? Benzene diazonium halide. Do you know what is benzene diazonium halide? Benzene diazonium halide is like this salt, benzene diazonium halide. It is unstable at room temperature, N2Cl, benzene diazonium chloride. Now if you do its reaction, that is known as redox reaction, if you want to prepare from this benzene, now how to do that, kids? If you use phosphinic acid, H3PO2, what is the name of this compound, kids? Remember that this is known as phosphinic acid. This is known as phosphinic acid. It will undergo oxidation to phosphonic acid, H3PO3, known as phosphonic acid. In place of this, you can use ethyl alcohol. Then ethyl alcohol will undergo oxidation to acetaldehyde. Now, by chance, if you're not provided with ethyl alcohol, you can use glucose. Even glucose can be used. If you are using glucose, kids, glucose will undergo oxidation to gluconic acid. Now if it is also not provided, then what you can use? You can use SnCl2, stannous chloride will undergo oxidation to stannic chloride. So they all are mild oxidizing agent or reducing agent, mild reducing agents because they are undergoing oxidation. So definitely this is our oxidizing agent. I hope that everyone got it. This reaction is clear, super duper clear. Is it visible to all of you kids? Do let me know. I have written very, very small. My dear student, just walaikum salam, assalamu alaikum, little cupid. MOA, yes, MOA, right. That is MRA, this is MOA, mild oxidizing agent. Very good. Though that's so nice of you kids, that's so nice of you. Now, from alkyl halides we can prepare. Now, 6th preparation, Baba is going to tell you the preparation number 6th. Are you ready for 6th preparation? Just see. 6th preparation, Baba is going to tell you. Just remember what can be the 6th preparation. The 6th preparation is from Rx, reduction of Rx. If I use any Rx and I reacted with LiAlH4. LiAlH4 is very costly, expensive. But remember that it is hydride donor. It is hydride donor. What is hydride, kids? What is hydride? Tell me what is hydride, kids? It is hydride donor. Hydride donor. Hydride is H negative. Now see, kids, this is Rx and X is always saying, you remember X always says, hey, I'm going. R is saying, please don't go away from my life. I like you. You are my love. but X is saying I want to go. Now one day LiLH4 has donated hydride. Now R asked to X, what you were saying that day? X was saying, no, I don't want to go. R is saying, hey, just go away from my life. I want to have hydride in my life. Now R positive, H negative, they will form bond and they will form RH. RH. Now the example of this is, you can take example of this C2H5Br. Now if you are provided with lithium aluminum hydride AiLiAlH4, it can be written like this, or it can be simply written like this LiAlH4, or they can write LAH, lithium aluminum hydride. In any way, any form they are going to write, you have to write C2H6. This is your hydrocarbon, you will get like this. Now this is the sixth preparation. I will give you those many preparations that whatever the number of things examiner is going to ask, it's all the ways what the examiner is going to ask, I will tell you each and everything. It's these many things you will not get any book. In any book you are not going to get. This is the quality content you will get each and everything right now at this platform only. Now 6 preparations I have told you. Now let's see the preparation number 7, seventh preparation. Seventh preparation is very, very important, my dear friends, from Grignard reagent. You must have heard the name Grignard reagent. Grignard reagent. Grignard reagent. What is Grignard reagent? Grignard reagent is an organometallic compound RMgX. RMgX. Now what is RMgX? Just see. R is always famous for donating electron, but magnesium saying, hey, you know, I'm being metal, I'm not going to accept your electron. Even I'm a metal, I'm a strong donor, so you have to accept electrons. So it is acting as minus I, see kids. You must have studied that always alkyl groups are plus I, but in this RMgX Grignard reagent, this is going to accept electron. It is an example of what? A marvelous example of an example of organometallic compound, organometallic compound. Now that means kids, this is carbon. So here we are having carbon bonded with magnesium and halogen, and this carbon is having negative charge. Now why I am telling you all these things? Because this will gain electron, and how it is going to form alkane. Any active metal which is going to donate active hydrogen, the one who can donate any entity having active hydrogen will give hydrogen to this, and this will gain hydrogen from that, and it will convert into hydrocarbon. Now see kids, you must be getting confused. It's looking idiyappam muruku, but Baba will make it romba sulubham. Then you will say arpudham. Now my dear friends, what are the compounds which are having active hydrogen? Baba will show you. Now let us suppose that I am provided with methyl magnesium chloride. Okay, this is our Grignard reagent. Fine kids, this is our Grignard reagent. Now if I'm going to react it with what? Water. Now water, hydrogen is active. Why it is active? Because this alkane, let me tell you, always alkane's pKa value is near about 50. These are the least acidic. If they are going to be least acidic, then its conjugate base R negative is going to be very, very basic. Now in front of this strong base, strongest base, all the compound which are containing hydrogen, that hydrogen will look like acidic to this base, strong base. Now it will take hydrogen from this H plus from this, and this is being negative charge. What you will get, kids? Hey sir, I will get CH3 and H, alkane. Yes, that's the right choice. Now, if any compound is containing H like alcohol, this is also going to give that. If any compound is having ammonia like hydrogen, that is also going to give. 1 degree amine, it is having active hydrogen. 2 degree amine, it is having active hydrogen, kids. Acetylene, this is having active hydrogen, kids. All they are going to give hydrogen to this. Alcohol having active hydrogen. Phenol having active hydrogen, kids. You got it? All the compounds will give active hydrogen to this, and this will ultimately form alkane because it is very, very strong base. R negative is very, very strong base and very, very good nucleophile too. Very, very good nucleophile also. Now till now it is clear, then do let me know, then I will show you the most important preparation, and after that I will tell you the chemical reactions. But I want to see, kids, your green signal. Baba want to see my students' green signal, that everyone is able to understand or not, kids. Only few minutes more, kids, then it will get complete. But before that, let me see. Sahana, wow, little Cupid. Kiran is there. Kushiga is there. Sausi is there. Sethi is there. Ratan. Ananya Kumar is there. Yeah. Jyoti Jain is there. Solitude is there. Now all the kids are there. My lovely kids. Now only few minutes more I will take, kids. Not too much time of yours I am going to take. Okay. Everyone, is it okay? Okay. Now the last preparation. The last preparation will come at Harry is there. Wow, Harry. Now Harry is there. Now this was the preparation number 7. Now Baba is going to tell you preparation number 8. 8th preparation. This is very, very important, and its name is Kolbe. Hey, bay, Kolbe's electrolysis. This is really very, very important. Kolbe's electrolysis. Have you heard this name, kids? How many of you have heard this name? Bay, Kolbe, 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 Kolbe. We can say, hey, Kolbe, Kolbe, Kolbe. Hey, Kolbe, Kolbe, Kolbe. Kolbe's electrolysis. Now, you want to see this Kolbe's electrolysis in detail, or you want to know the trick? So let's see the trick, kids. Your examiner will give you a question like this. Suppose he is going to give you a question like this. CH3, CH2, COONA, aqueous, and current. I is current. He will supply current. Now this is Kolbe's electrolysis, and he will ask for the answer. Now kids, should I tell you in detail, or should I tell you the way in which you can directly get the answer? Kids, I want to see your answer in the chat section. Everyone, detail, then show me fire. Short trick, then show me green hearts, and both the two methods, then both. Green hearts along with the fire. Hey everyone, Baba is waiting for your answer. Green hearts with fire, and what do you want? Let me check it out, my dear students. What do you want? Baba will go according to that. Kolbe's electrolysis. Kolbe's electrolysis. Yes, kids, yes. So both So let me tell you first the trick, then I will tell you in detail. Wow, maximum students, they want trick first. Okay, now see the trick. Baba is going to give you the trick. Mind-blowing trick. Mind-blowing trick. Which trick? Baba HSP's trick. Baba's trick. Who is Baba? Your Baba HSP. Now see, this trick is for Kolbe's electrolysis. For which? Kolbe's electrolysis. Now see to this trick, kids. CH3, they have given you CH3, CH2, C double bond O, Na plus water. Water is HOH, right? Now just duplicate it. Just duplicate it means double it. See, duplicating. Let me duplicate it. CH3, CH2, C double bond O, Na plus water. Right, kids? Supplied current. Now see, kids. The bond will break from here. The bond will break from here. Ta ta ta. Ding 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 ding. Ta ta ta. Ding 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 ding. Now they will combine. Are you able to understand? They will combine. Ting ting ting. I'm going to combine with this. It has broken from here. It has broken from here, so it will combine like this. Ting, 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 ting. I want to be yours. So the bond will get formed and they will be like this. Just see. CH3, CH2, CH3, CH2. Now bond has been formed in between these two compounds. Just see. This bond, the new bond has been formed. You are able to understand? First point. Okay. This is 1 mole. Now see over here what is going to happen at this place. Just see, kids. This will go like this, CO2, and it will also go like CO2. 2 moles of CO2 you will get at this place. 2 moles of CO2 you are going to get at this place. 2 moles of CO2. You will get 2 moles of CO2 plus 2 moles of CO2, and this will happen at anode. These two things are getting formed at anode, kids. So how many moles of gas you got at anode? 1 mole of this, 2 moles of this. So you got 3 moles of gas at anode. 3 moles of gas at anode, kids, you got. This point is clear. Till now, is it clear? Keep on showing green hearts if it is getting clear, kids. Now, so what you are going to get at cathode? Now, this NaOH, OH negative will combine with Na plus. It will combine with Na plus. Just see, kids. So, it is going to combine. This Na plus and OH negative will combine to form NaOH. This will happen in this solution. 2 moles of NaOH you will get in this solution. 2 moles of NaOH you will get in solution. And we know that NaOH is basic. So the pH will increase or decrease during as the reaction is proceeding. pH will keep on increasing or decreasing. Kids, do let me know in the chat section. pH will increase or decrease as the reaction is getting proceed. So pH will keep on increasing. Now what is left? This H. Now this will combine and my dear students, you will get hydrogen gas at cathode. So at cathode you got 1 mole of gas. At anode you got 3 moles of gas. So if examiner is asking at anode compared to cathode, the ratio of the gas is 3:1. Everyone got it? Just to let me know. And then I will give you one tough question. But first of all, do let me know, is it clear, kids? This trick is very good trick or not? This trick is really awesome or not? Kids, do let me know. How was the trick? Everyone just do let me know how was the trick, kids. Everyone just to let me know. This was really nalla irukum, Rapudham, very good trick. Now kids. Now let me tell you in detail. Kids. Let me tell you in detail. Now my dear students, before I tell you in detail, one more thing is there about it. Just see, one more type of compound will get formed, but that you will come to know whenever Baba is going to tell you the trick, then only you will come to know what is that. Just see, kids. If I say this is, wow. If I say this is anode, this is anode, and if I say this is cathode, so the anode will carry positive because attached with the positive terminal of the battery, negative terminal of the battery. Now in this electrolytic tank, Baba is going to tell you in detail always. Now you have seen that there was CH3CO, CH2, COO negative anion and OH negative anion, and there was Na plus cation and H plus cation. 2 types of cations, 2 types of anions. Definitely whenever you are going to start, you connect, the anions will move towards anode. Both the anions, they are having negative charge, they will move towards anode, and both the cations, they will move towards cathode. But everyone cannot get reduced or oxidized. The one who is having maximum tendency to undergo oxidation reduction, they will do that. Now here this is having maximum tendency to. Remember that at anode always oxidation takes place. This is the fact. Always oxidation takes place whatever the cell. So CH3, CH2, just see, CH3, CH2, COO negative will undergo oxidation to give you what? CH3, CH2, C double bond O free radical. This will get formed. Now from here 2 options are there. Just see, let me tell you kids, this will break to give CH3, CH2 free radical, because my dear students, we know that carbon dioxide is very good leaving group. Carbon dioxide is very good leaving group. So carbon dioxide will eliminate out as gas. Now this can combine, dimerize, and once it is undergoing dimerization, you will get CH3 combined with the same molecule CH2, they will form butane gas that we have formed at anode, C4H10 and 2 moles of carbon dioxide, because if we need 2 moles of this, so we have to take 2, then we have to take 2, then we have to take 2. So 2 moles giving out 2 moles of carbon dioxide. So 2 moles of carbon dioxide, 1 mole of butane. But at the same time, at anode, what other thing is going to happen? Just see, kids, if this molecule, this carboxylate anion, see this carboxylate anion CH3, CH2, COO free radical can combine with this ethyl free radical, CH2, CH3, they will form what? I want to see the answer in the chat section. Once they are going to combine, they will form what? Definitely they will form ester. Esters will give fruity smell. So the product will be CH3, CH2, COO, CH2CS3. In AIMS they have asked this question, and IIT JEE Advanced they have asked this question, that in traces what you will get. So you will get in traces ester. Ester you will get in traces. Kids, are you getting my point? Ester in traces. In traces you will get ester. Now this is all about anode. Now Na plus NH plus, who is having more power to undergo reduction, whose SRP value is maximum. So H plus is having maximum SRP. SRP, standard reduction potential value, is more. So definitely it will undergo reduction. It will take 2 electrons. Now it will form hydrogen gas. Hydrogen gas. Now what is left in the solution? From this side OH negative is left, and from this side Na plus is left. So it will form NaOH. I think each and everything is clear in detail. Just see to it and do let me know, kids. Those who wanted to know in detail, have you got it? If yes, I want to see green signal, kids. Kids, everyone do let me know. Everyone, kids, do let me know in the chat section. Everyone, kids. Very good, very good, very good, very good. Now the chemical property. Thank you, Sausi, Jyoti Jain, Solitude, HSP, and Sahana. Thank you. Now, all the preparations Baba has told you. Now, let's see the chemical properties. Are you ready for the chemical properties, kids? Is everyone ready for the chemical properties? Only few more minutes for the chemical properties. Baba is going to tell you. Da da da, the music. Ding ding ding. Chemical reactions of alkane. Chemical reactions of alkane. Baba is, oh, this is chemic. Oh, what is this? Chemic. Sorry, kids. Sorry. Chemical reactions of alkanes. So, do you know most famous chemical reactions of alkane? Anyone? Any hint? Most famous reactions of chemical reactions of alkane. Any idea about it? Anyone is having any idea about it? That is none other than FRSR. What do you mean by FRSR? Free radical substitution reaction. And to have these type of reactions, what type of conditions is required and what indication will be given over there? How will you determine that this type of reaction will take place? So remember that in Hindi I used to sing song Suraj hua prachand, FRSR hone laga, means once too much heat is there or sunlight is there. So there are two indications for this reaction. Either this reaction can take place, hey Baba, photochemically. Photochemically means what should be given over there? How will you find out that photochemically? Photochemical indication will be either they will give you sunlight, or they will say UV rays, or they will say H nu, they will talk like this. If sunlight is given, H nu is given, UV rays are mentioned, or diffuse sunlight, they are talking about diffuse sunlight, then remember that they are talking about what? They are giving hint for what? They are giving hint for photochemical FR/SR. Because in the examination, Baba will not be there to tell you that, hey kids, just they are asking about free radical substitution reaction. Just they are not going to tell you. No one is there present. No one is going to tell you what you have to think. You will be there, the paper will be there, and the whole number of people were there, but you will not be able to ask. And to whom to ask? They all are like you only. What you will ask with them? Now, my dear students, second indication for this will be thermally. What mally? Thermally or thermally. How to see thermally? In thermally, you have to remember tofu C. Tofu C. What is tofu C? Now, this is very, very important. Tofu C. Now, T is for 300 to 500. Now, kids, degree Celsius. Now, this is the maximum people, they are getting confused or trapped by the degree Celsius or Kelvin. Now, you will say, sir, 300 or 200. Okay, it can be 200 to 400 also, you can see. Then also it will work, but degree Celsius. This is thermally. Now, Baba is going to tell you. Are you ready, kids? Is everyone ready? But Baba is going to tell you, Baba has told you TFC. Remember that TFC, tofu C, 300 to 500 or 200 to 400 means the range is from 200 to 500 degrees Celsius. Anything if you are placing it, then temperature. Yes, temperature is going to play the most important role. Now, my dear friends, before I start this chemical reaction, because alkane is the least reactive, alkane is neither polar nor having pi bond, that it will require high temperature, drastic conditions for its reaction. Now, see kids, if I say that I am provided with methane, now see kids, if you add fluorine, you know, dangerous thing. Either it is in dark or in sunlight, it will kill the compound and will make carbon black, No more compound will be there, carbon black, everything will become black. Now, if you react with chlorine, see it's Cl2, in dark, no reaction. If you add chlorine in presence of sunlight, or Cl2, 450 degrees Celsius temperature, they will make compound. Now, two possibilities are there, What are these two possibilities, kids? Possibility number one, you will get CCl4, CHCl3, CH2Cl2, methyl chloride, 4 types of chlorinated products. 4 types of chlorinated products. But this is possible only when chlorine is in excess. So this is possible when chlorine is in excess. So this is case A, when Cl2 is in excess. Now B, if Cl2 is less, limiting reagent you can say, or less you can say, limiting reagent. If Cl2 is limiting reagent, we will say methyl chloride will be the product. Now I hope you got it. Now, if the reaction is carried out at 12 noon, that means very high temperature, 12 noon, then remember that it is also going to form carbon black. Carbon black. This point to be noted, my lord. And why this is happening, let me tell you that fluorine is highly reactive, then chlorine, then bromine, and then iodine is least reactive. This is the reactivity order. Reactivity order, my dear friends. Are you getting my point? Now, kids, number of types of questions will come on free radical substitution reaction, and you have to pay attention. Are you ready, kids? I will take only 20 minutes. My dear friends, everyone, are you ready? Is everyone ready, kids? Just I will take 20 minutes, not more than that. Motivation, I don't know. I know only chemistry. Muhammad Shamil, I know only chemistry, and that is the best motivation. I would like to say I know only chemistry, and that is the best motivation, kids. Hit the like button, make it 100. Everyone, just to let me know. Are you ready? So Baba is going to tell you. Now, see, kids. Everyone, just see what I'm going to tell you. Kids, see. The table I'm going to give you, this table will play very, very important role. This is experimentally determined table. The table Baba is going to give you, this is being experimentally determined table. Now see, let me divide it. One part, second part, third part. Experimentally determined table. Experimentally determined table, kids. Just see. If I tell you that here is, okay, why I am going to compare and for what I am going to compare, just see, fluorine. Have you ever gone for shopping along with your father? Have you ever gone for shopping along with your father? Now, father is, in my time, I don't know what's in your time, but in my time, whenever we were going for shopping along with father, father was saying, just have this thing or that thing, do it fast, just make it fast. Sometimes he was explosive, vigorous, and that time we were not able to control him. Father is too much reactive, kids. Do you remember? I don't know about your father. My father was like that. Very, very highly, very, or you can say can't be controlled. Reaction is explosive reaction, fast reaction, explosive reaction. So fluorination is generally not carried out. And whenever I was going to market with mother, in Maharashtra, mother is known as I was going to this shop, that shop, and but not purchasing anything. She was saying, I will come tomorrow and I will have it. Very, very slow. Very slow. In my time, I am talking about my mama, not your mama, right? Very slow. So, neither we are going to do fluorination nor we are going to do iodination. We are interested in chlorination and bromination. We are interested just in what? Chlorination and bromination. So, each and everything, our focus while doing the halogenation of alkanes, our focus will be where? At chlorination and bromination. Are you getting my point, kids? Everyone, are you getting my point? Why our focus will be at chlorination and bromination? Because they are going to give good yield. Only they are going to give good yield. And out of chlorine and bromine, let me tell you, my dear students, this chlorine is more reactive, and the one who is more reactive is less selective. Less selective. And bromine is less reactive. Less reactive means more selective. Now what is the meaning of this? More reactive, less selective, less reactive, more selective. How many of you want to know the meaning of this? How many of you want to know the meaning of this? My dear friends, if you are hungry, if you are too much hungry, then you will eat samosa. You will dip the samosa in the sauce and you will start eating. But if you are not hungry, you will say, oh, it's too oily. You know, I don't like oily things. My mother said, no. Use carrot. Eat some fruits, carrots. I don't want to have samosa. Oh, please have it. Then that candidate is going to take out some papri or the potato and he will say or she will say, oh, remove it. I don't want to eat. Now what is this? Oh, stuffing is not good. Like that. That means they are not that much hungry. So once you are not hungry, you are more selective. You talks like that. Am I right or not? Let me see in the chat section, kids. Am I right or not? Am I right or not? Tell me in the chat section. Am I right or not? Everyone, show me green signal if I am right. Whatever I am telling you, if I am making sense, kids. Everyone, just do let me know. If I am 100% correct, then do let me know. That yes, sir, whatever you are saying, that is absolutely correct. Yes, now I have seen. Very good. Now, see, kids. See. Before I write down this data, let me tell you the free radical stability, free radical who is most stable. So I will say 3 degree free radical is more stable than 2 degree and then 1 degree. This is the stability order for free radicals. Free radical stability. Right, kids? Free radical stability. Now let me tell you, my dear students, for chlorination and bromination, I am going to give you the data. Just see. If I tell you for 1 degree hydrogen, 2 degree hydrogen and 3 degree hydrogen, see the selectivity. Chlorine is saying if I love to remove 1 degree hydrogen, this is 1 point. Then this is 3.8 times more and this is 5 times more, and this is experimentally determined data for both. Now bromine says, oh, only this much of difference. Now kids, if you are not able to understand, I will tell you with example, okay? Just wait. Bromine says if I love this 1 degree, my love is 1, then I love 82 times more 2 degree hydrogen and 1600 times more my love is for 3 degree. This data, if you remember, kids, and you have to remember, then only you can solve tough questions. Should I tell you? If you are able to learn this data, just to let me know in the chat section. If you can hold this data in your hippocampus, then only I will tell you how they will give you tough questions and how to solve those tough questions. Kids, do let me know. If you say yes, then only Baba is going to give you. Very good, kids, very good. Everyone, now see, kids, everyone just see. Everyone just see how this data is useful. Now I'm going to make this chart. You have to help me. Then only you can understand. Baba is going to make this chart once again with your help. Help me. Let's see how many of you got this in your hippocampus. First tell me that I'm writing for chlorination, bromination, that here I have written chlorination. Cl2, here I have written bromination, and this is 1 degree hydrogen, this is being 2 degree hydrogen, this is being 3 degree hydrogen. Now complete it. What should I write over here? Everyone just to let me know, what should I write over here? I want to see in the chat if you're ready. 1, then 3.8, then 5. Now out of these three things, which data you will forget? First of all, do let me know, what do you think, which data is tough to remember out of these three? Then people will say, sir, this data is looking a little bit tougher to remember. Tell me kids, is it looking tougher? Do let me know, this 3.8 is looking tougher. If yes, tell me. Now see, we are studying chemistry. By chance, if you forget 3.8, remember CH for chemistry. CH for chemistry. Chemistry is CH. Now, if you see in A, B, C, D, A, B, C, D, E, F, G, H. Now see kids, A, 1, 2, 3, 4, 5, 6, 7, 8. Now CH, 3, 8, 3.8, 3, and this is 8, so 3.8. How is it? How is the trick? I want to see first in the chat section. Everyone do let me know, how is the trick? How is the trick, kids? Hey everyone, if you are really liking it, show me some fires, some green hearts, kids. This is not good that you are sitting and not legendary technique. Harry, thank you. Thank you, Harry. Thank you. Now see kids, this is the way how we can understand, how we can learn. Now see kids, see for this one, see for this one, 1, then 82, then 1600 times more. Now how we are going to use it? Now let's see the use of it. Let's see the use. Now examiner will give you question like this, that CH3, CH2, CH3. First question he will give you that if I have done chlorination, Cl2H nu, how many types of products you will get? How many types of products you will get, kids? Tell me how many types of products you will get. Then you will say, sir, I will get CH3, CHCl, CH3 plus CH2, Cl, CH2, CH3. So 2 types of products we have got. Now, if the examiner is asking which will be major, this one. So definitely this is going to be major and that one is going to be minor. So whatever you are thinking, you are getting the same product. So if I say this is A and that is B. Now, but if the examiner is asking what amount, what percentage of A you have got, then that is going to create problem, the percentage of A. Now see how to find out percentage of A. Once the percentage of A is clear, subtract from 100, you will get the percentage of B easily. Now my dear student, just see how many 1 degree hydrogen we are having in the reactant. This carbon is attached with one more carbon, so definitely this is 1 degree carbon, and that carbon is also attached with 1 degree carbon. So hydrogens 3, 1 degree hydrogen 3. So this compound is having 6 hydrogens. They are being primary, or we can say 1 degree. Am I right? Now these two are secondary hydrogens, because this carbon is attached to that side, also carbon this side. So this carbon is secondary, 2 degree carbon. So hydrogens are 2 degree hydrogens. So we are having 2 hydrogens, they are being secondary, 2 degree. Kids, till now is it clear? If till now it is clear, then Baba will tell you how to find out the percentage. Now we want to find out percentage of A. In A, the chlorine is attached to which carbon? Chlorine is attached to 2 degree carbon. 2 degree carbon. So that means 2 degree hydrogen must have been replaced, because chlorine is added to the 2 degree carbon. That means 2 degree hydrogen should have been replaced. Now, in A, 2 degree hydrogens have been replaced. So how many 2 degree hydrogens are here? 2. Just always see, whenever you want to calculate percentage, don't see the product, see the reactant, because reactant is going to decide product. So 2 hydrogens, we are having 2 degree. Now what is the reactivity of chlorine for 2 degree hydrogen? Reactivity of chlorine for 2 degree hydrogen, just tell me. Reactivity of chlorine for 2 degree hydrogen is 3.8. So I will multiply. So what I will do? I will multiply 2 with what? 3.8. Till now is it clear, kids? Now in the denominator, what I will write? Whatever I have written in the numerator, I will write this 2 into 3.8 plus something else I will write. What I will write? Because there are 1 degree hydrogen. How many? 6. And what was the reactivity for 1 degree hydrogen? 1. And now in your school time, how you were calculating your percentage, whatever the marks you got in the numerator and whatever the marks of total paper in the denominator, multiplied by 100. Multiplied by 100. Now solve it, kids. Please help me. 3.8, 8 to the 16, 6, 3 to the 6, 7, 7.6, 7 and 6, 13.6. 13.6 into 100. Now the table 14 more than 50%. More than 50%. If anyone is having calculator, then do let me know. 14 पंचे 70, 70 6 14 पहले 14 56 14 पंचे 60. 56% approximately. Roughly 56%, kids. Do let me know in the chat section. Is it roughly 56%? Yeah. Baba's calculation is mashallah very good. Baba's maths is good or not, kids? Do let me know. Baba has done fast calculation or not? Baba has done really fast calculation or not, kids? Do let me know. Everyone do let me know. Yes. Now the second one is less, that is going to be minor, and definitely its percentage will be, if that is 56, so this will be 44% approximately, right, kids? 44%, right? Now if the same reaction would have been carried out with bromine, bromination, then see what will be the product. Just see CH3, CH2, CH3. Once again, let's see, we will carry out bromination, then see the difference, then each and everything will get cleared. CH3, CHBr, CH3, CH2Br, CH2 and CH3. Now see, kids, the percentage of X. Let's see the percentage of X. This is X, and then percentage of Y. Let's calculate, and then I will write over here, right? Now let's see percentage of X. How to calculate percentage of X? Everyone help me and do it yourself. 2 degree hydrogens are 2. Reactivity is 82. So 2 into 82 plus 6 into 1 into 100. How much I will get, kids? How much I will get? 82. 2 to the 4 and 8 दूनी 16. 164 upon 6. So 8 दूनी 16, right? 8 दूनी 66. 64 and this 6. So definitely 170 into 100. it will come out more than 90%. How much kids? Do let me know how much it is coming. Use calculator and do let me know how much it is coming, kids. Everyone do let me know. Do let me know how much it is coming, kids. And hit the like button, smash the like button, kids. Make it 100. Yes, how much? 97 or 96, approximately 96%, kids. 96%. So how much selective it is? It is coming 96%. So see the selectivity. You will see, you will judge the selectivity. Now my dear students, let me give you that question where you people are going to get failed. Should I give you that question where most of the people are going to get failed? Just see, the question is very fantastic question, kids. Find out major product for CH3, Cl2H nu. Now there are two options. Option A is CH3, Cl, CH3. There is B option, CH2, Cl, CH3, H, CH3. So out of A and B, you have to tell me the answer out of A and B. Only two options, kids. Only two options. Do let me know. Let's see. Thank you, Saucy. Thank you, kids, Sahana and Saucy. Now tell me B. Oh my God. Harry Heron is going for A. Jyoti is going for B. Kids, how intelligent you are. How you got it? B is the correct answer. Now in the first sight, everyone will say A is the correct answer. But kids, B is the correct answer and you got it. Now why they will say? Because here this is 3 degree hydrogen and they are being 1 degree. But remember that you must have heard one story that if anything is more in number, then that is having more value. If ants, they are more in number, they can kill even human being. One human being, crores of ants, they are having more power. Unity has more power. Now let me prove it, kids. Let me prove it. See, the percentage of this compound, how to find out, just see, and that's here. The experimental data will prove percentage of B will be the primary hydrogens. There are 9 primary hydrogens. Can you see 9 primary hydrogens we are having, kids? And only 1 tertiary hydrogen I am having over here. Right, kids? Now see, when we are going to calculate this one, 9. So 9 reactivity is 1. So 9 plus the tertiary hydrogen is 1 and its reactivity is 5. See, tertiary hydrogen is what? 1 and its reactivity is 5. So I will write 1 into 5 into 100. So how much I will get? I will get 9 upon 14 into 100. How much it will come out, kids? 9 upon 14 into 100. How much it will come out? Use calculator and do let me know. 9 upon 14 into 100. How much it will come, kids? How much it will come? Do let me know. This question we generally give to teachers. We are going to appoint teachers as faculty, and we are generally giving such type of questions to them. How much percentage it will give, kids? Just to let me know. Definitely it is going to be more than 50%. It is going to be more than 50% or not, kids? Do let me know. I want to see your answer in the chat. Kids, I'm waiting for your answer. Baba is waiting for your answer, kids, in the chat. Do let me know. How much? How much, kids? 64.2. So definitely this is the winner. 64.2 is the winner. Now, kids, all these things Baba has told you, kids. Now the mechanism, only the mechanism part is left. It will take, I think, 5 to 7 minutes. Will you give that much time? Are you ready for that, kids? Do let me know. Are you ready to give me that much time for free radical substitution reaction mechanism? Kids, do let me know. Everyone, just to let me know. Are you ready for that mechanism of free radical substitution reaction? Wow, ready. Now see to it. Suppose your teacher has given you question like this, that CH3 plus Cl2 is doing reaction with H nu. Now, what are the products you will get and how the reaction is going to take place? That is the most important thing. Now, the step number 1 of mechanism, step number 1, that is what? Chain initiation. Remember that? What is that? Chain initiation. And what is going to happen in this step? Chain initiation. In this step, free radicals are going to get generated. Free radicals will get generated, kids. Free radicals will get generated. Free radicals are generated, kids. How they will get generated? Now see that we are having Cl2, we are having carbon-carbon bond, we are having chlorine-chlorine bond, we are having carbon-hydrogen bond, but this is most unsymmetrical, and that's why it will break from here with fish hook arrow. This fish hook arrow means one electron will be taken by this chlorine, one by this, or you can say it will break from here. Homolysis, homolytic cleavage, homolysis, symmetrical breaking, then you will get 2 chlorine free radicals. This is chain initiation. Gets everyone got it? Chain initiation, just to let me know. The first step of the mechanism, remember that this is very, very important. Chain initiation, kids. Sir, enough. Ratan Shetty, just 5 minutes. Just 5 minutes more. Ratan Shetty, just 5 more minutes. Because let me complete this, then it will get completed. You are very good student, I understand. Ratan beta, Ratan, just 5 minutes more. Say yes, little Cupid. Koshiga, because Alkane I have to complete, and just mechanism is going to take 5 more minutes. You are very, very good students. That's why I am telling you this. Very good, very good. Now, chain initiation, free radical has been formed. Now, step number 1. After step number 1, Baba is going to tell you step number 2. Step number 2. chain propagation. What is going to happen in chain propagation? I will tell you. Chain propagation. Now in chain propagation, this chain propagation takes place in two sub-steps. It takes place in two sub-steps. They are very, very important point. Kids, examiner will ask, what are these two sub-steps? Now see, kids. Chain propagation sub-step 1. Sub-step 1. This is very, very important, kids. Sub-step number 1. 1. See, there is CH3, CH2H. Now definitely chlorine free radical will break this bond. Now the option is there whether chlorine is going to form a bond with hydrogen or the chlorine is going to form bond with carbon. That is the most important point, because this chlorine can combine with this hydrogen or the chlorine can combine with this carbon. There are two options in the life of this chlorine. Let's see and let's compare, and why not. Just see, there are two ways. That one thing is that if it is going to combine with carbon, it will look like this, and hydrogen will be the free radical. And if it is going to combine with hydrogen, then this one is going to be the free radical. It will form HCl. Now it all depends on the stability of the bond, and remember that, my dear friends, mark my words. Let me tell you clearly, this bond is more stable bond. More stable bond means its activation energy EA will be less. That means this path is more feasible and this path is more feasible. That path is not feasible. So EA will be high. Higher activation energy required, low. So you got alkyl free radical. Remember that this is going to change each and everything. This is the most important thing, kids. Alkyl free radical will get formed. Free radical, and once the free radical, we know that this is an intermediate. An intermediate, kids. Intermediate. That means the rate of FRSR. This is the most important point of this chapter, kids. Rate of FRSR is directly proportional to what? Mark my words. Let me tell you, kids. Rate of FRSR. Rate of FRSR, free radical substitution reaction, is directly proportional to stability of free radical. Stability of free radical, stability of free radical, and that's why this point holds a hell lot of weightage. Stability of free radical, kids. Are you getting my point? Everyone, are you getting my point? Just to let me know. Yes. Now, chain propagation, second point. Chain propagation, sub-step 2. Sub-step 2. What is going to happen over here? Just see, kids. We got this free radical, alkyl free radical. This will combine with chlorine. It will break this bond. Now once the chlorine was broken by sunlight, and the second time the chlorine will be broken by whom? By this alkyl free radical, and you will get your product. So one of the main product you got not in termination. You have got it just in the sub-step B of propagation, and that is the most important question of your examination. Now, let me tell you, third step is chain termination. Chain what? Chain termination, kids. Chain termination. Now see what is going to happen over here. most of the free radicals will get consumed. Almost all. Most of the free radicals will get consumed over here. How they will get consumed and how many types of reactions. Now, if chlorine is excess, chlorine will combine to form Cl2. First thing, if ethyl free radical is there, then ethyl will combine in two ways. What are these two ways? One way is that it can combine to form C4H10. Another way, it can undergo disproportionation reaction. As earlier I have told you, disproportionation, CH2 double bond CH2 plus ethane, it will form C2H6, it can form. So these many ways the product is going to get formed. Now see, ethylene in traces has been formed, and this can be explained in this way, kids, in traces. Now only one question I have to tell you, and after that the class will get over. Are you ready for that? Because that is going to be very, very important thing. Now my dear students, if question is coming like this, that I am provided with, this is the brilliant question, many exams have asked this question, that I am having propene CH3 CH double bond CH2 and is going to react with Cl2H nu. One reaction is Cl2H nu, it is showing reaction with Cl2H nu, and another reaction, if I say it is just reacting with Cl2. Now what is the difference in between these two things, kids? Now remember that this is simply electrophilic addition reaction. It will attack on the double bond and the product will be CH3 CHCl and CH2Cl. This is the product. But once it is going to react with this, then the free radical stability will be like this. It's this free radical is resonance stabilized. That remember this. It is resonance stabilized by resonance. So your product will be CH2Cl CH double bond CH2. And this was a simple question, my dear students. If they are going to ask tough question, just see how they will ask. Just see, if they have given you benzene and attached CH3, so it will become toluene. And toluene, if they have given toluene and they are asking how will you do the reaction, if the reaction is taking place, once the reaction is taking place like Cl2H nu, and once they are giving that it is reacting with Cl2 anhydrous AlCl3. Now my dear student, this is an example of electrophilic substitution reaction. So ortho and para, two types of products you will get. CH3 chlorine will be over here and CH3 chlorine will be over here. That two types. But this has been an example of free radical substitution reaction. So first you will get benzyl chloride. Remember the name, my dear students, this is known as benzyl chloride, because name is very, very important. Now once again, FRSR Cl2H nu. So you will get benzyl chloride. Benzyl name is very, very important. 2 chloride divalent benzyl chloride. So this is going to be the last question, kids. So now once again, Cl2H nu. Now you will get benzo trichloride. CCl3 benzo trichloride, or simply they can give you benzo chloride. Benzyl, benzo. So this is over and out. This is all about. Now this class got over. Now this was all for today, kids. Your hydrocarbon alkane got completed. My dear students, Ratan Sethi, got it? And thank you everyone for being with Baba. But those who are new, you can hit the like button. How to improve organic just watch my lectures. Benzyl, benzo, yes. You will get full marks whether you are preparing for IIT or you are preparing for NEET. Definitely you will get full marks, kids. Just follow my lectures, and really, kids, thanks. Because whenever any student is really doing hard work, always Baba says that Baba is feeling accomplished. Because you are making nation. If you are really working hard, you are making nation, and Baba and the team is there to provide you the best content. We are not teaching for views. We are teaching for giving you the best knowledge. And let me tell you, this is our team, kids. I've told you in the starting also, and you will never get such type of dedicated team, kids. This is the best team, and let me tell you, kids, no one can match with this team, kids. The 4 members, the best, kids, the best 4 members. Let me tell you, my dear students, because nowhere you are going to get this great quality content. Mark my words, kids. If you're the part of this team, definitely your rank is waiting for you, kids. No one can stop a person with high willpower, and no one can stop the student for getting rank if that student is the part of this Avengers team. Let me tell you, kids, because what I am telling you, I mean it. You can ask your seniors. They will tell you that directly they got questions what these teachers, including me, they taught them. Direct questions in the examination they have got, kids. And the concept clarity, if I talk about the concept clarity, that each and everything will come from the notes. And if you are unable to understand, my dear students, let me tell you one thing. If you are unable to understand anything, we are having number of ways. You can ask these kids, those who are studying at Jaipur, offline coaching kids, ask them. Baba is teaching for JEE also. Always, I never compromise with the quality of content. Now, at the same time, I am giving you tricks also, how to make, how to increase your speed. Not only me, all the teachers from our team, each and every member is giving tricks. And accuracy, kids. If 2 things are there, the accuracy and the speed. For accuracy, you need visualization, understanding of concept in detail, and for speed, you need tricks. Speed into accuracy is going to give you marks, and the rank, full marks, kids. Nothing can stop a person with high willpower, and those who are having that willpower, definitely your success is waiting for you, kids. Let me tell you this particular thing. Thank you, kids, and spread this thing, kids, everywhere. Nimbus Pro batch for class 11th students, and this is Phoenix Pro. Every student is having dream, kids. Number of students are there, those who can't join offline coaching. It's the best chance. Just for rupees 5,999, kids. Offline coaching, they are charging 2 lakh rupees for 1 year, 2.5 lakh rupees for 1 year, number of coachings. And in between the classes, during the session, their teachers are going to other coaching, they are joining other coaching. Then how they are feeling after paying 2.5 lakh rupees. In the name of the teacher, they have joined that coaching, and the teacher is not there. But here, just you see, this team is being permanent. All the faculty members are permanent. You see, the last year, see, just compare this year, all these teachers are same. Mark my words, categorically I am telling you this particular point, my dear students, that permanent team is required, first thing, and that consistency is required, and the teacher should have both the 2 things. The content wise, he should or she should be very strong, and the quality of delivering that lecture If each and everything is there, then who can stop your rank, kids? Am I right or wrong? Only this much Baba will say. Now, pranam, dhanyavad, thanks a lot to each and everyone. Be the part of HSP and Army at your Unacademy NEET English channel, and those who have not, smash the like button, smash it, make it 100. Now I will see in the chat section. Good night, sayonara, bye to all of you. Khuda Hafiz, walaikum salam, assalamu alaikum, pranam, shubratri, shabak khair, bye.